Hello everyone, you have made it to the last day of video notes for Unit 6. So we're doing the 6.3 video on quadratic applications, day 2. So this is the second day. There isn't anything new, but just a couple things to reiterate. When you're dealing with quadratic function word problems, it's best to persevere. When you quit and give up and don't put anything down, that is really when the problems happen. But the more work that you can kind of pull from the question, or the more numbers or things that you can pull from the question, the better of a chance that you are going to get something or partial credit on one of these questions. All right, number one, let's dive right in. So the vertical motion formula of an object is given by h equals all that jazz. There's a lot of variables, so they tell you h is the height. They tell you that t is the time, and they also tell you that v is the initial upward velocity. Oh my gosh, and another one. And c is the starting height of the object. Okay, so Michael, he's going to kick a football in the air and then gives him an initial upward velocity. So what color should I highlight that in? If you said orange, you are correct. And it said the starting height of the football is 3.5 feet. To me, that looks like that's c. So there's the 3.5 feet. If no one catches the football and it lands on the ground, how long will the football be in the air for? All right, so if I'm trying to picture this and you have somebody kicking a football, they're going to kick it and it's going to kind of make an upside down parabola and eventually land on the ground. So already I'm thinking in my brain what this would look like. The first thing that we need to do, however, is get rid of variables or use some substitution to help us out. So we can't put anything in for h or t. But the great news is they told us that v, the initial upward velocity, is 50, and then that c was 3.5. So what we just did here was I substituted in 50 for my v and 3.5 for my c. As you can see, we have a quadratic equation now, if you couldn't tell from before, and it tells us here that we need to round to the nearest tenth of a second. What that tells me is that this is not going to be a nice factoring question. We're going to have to pick a different method, and just looking at it, I can tell that there's a couple of variations. It didn't tell me what I should be doing here, whether or not I need to solve it algebraically, but let's go ahead and do that. When I look at a graph of this, this is this graph. Notice how I used x values because my calculator doesn't understand t's. And maybe what we need to do here is change this something to, I don't know, is 50 high enough? Maybe not. Oh, it is. Okay, perfect. I could even change this to 7 and get a little bit smaller of a window just to see that nice, pretty parabola. But really what we're trying to find is that 0 that's happening right here, which happens to be at 3.19-ish. All right, so we know that that's this point value here. We need to find that algebraically. So the way that I'm going to do that is using the quadratic formula. I hope you were thinking that in your head. Here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, there it is. Next step, skeleton template it up. That's right. You probably don't need me for this. Hopefully this is becoming pretty straightforward for you. In fact, I want you to do the next 2 steps on your own. I'm going to pause the video and I'm going to meet you back here in another couple minutes. All right, so here I have my substitution done. I put the number in and I got to this point and I realized since it said round, I don't have to go any farther. So I am finding the value of x, and really we get 2 of them. We're going to round both of them. I typed them in my calculator to save me some time. So it said rounded to the nearest tenth, so that would have to be negative 0.01, and x equals 3.2. Which answer doesn't make sense? The negative, because obviously we're dealing with time. In this case, it would be t equals. So that really is our t value. And t equals 3.2 seconds. All right, moving on to number 2. Okay, A contractor has 48 meters of fencing that he is going to use as a perimeter of a rectangular garden. Okay, cool. Let's draw a picture. They said that it's a rectangle. Let's draw a rectangle. We know that we have the perimeter is equal to 48 meters. What else do they tell us here? The length of one side of the garden is represented by X, and the area of the garden is, so here's X. The area of the garden, interesting. So the area, actually, I'm going to draw a whole new picture of the same rectangle. So I'll try to draw as similar as I can. So they said the area is going to be equal to 108. Okay, well, if that side is X, then that side is X. If this side is X, that side is X. Although it really doesn't matter for area, I could just leave one side off so I don't get too confused. Perimeter is adding all the sides. Area is multiplying. But here's the deal. We don't know any relationship for the other side, so I don't know about you guys, but I think I'm just going to bring in a Y. Let's bring in a Y. We don't know it. Okay, so we do have information. It looks like we might have to have two equations because there's a perimeter. We know that the perimeter is equal to 2x's plus 2y's, right? 2x's plus 2y's. And then area is going to equal to, 108 times, or is equal to x times y. Well, this is bizarre. This is a little tricky, to be perfectly honest with you guys. We can't have an x and a y. We got to have all x's or all y's. So I think maybe manipulating this equation over here might be a better opportunity for us because that multiplication kind of scares me a little. So let's solve for x over here. If I do that, I'm going to get 48 minus 2y is equal to 2x. So all I did was bring over the 2y to the other side. If I divide every single term by 2, that's going to leave me plain old x. And I like that because if I know what x is, I can substitute that in over there. So 48 divided by 2, 24 minus y. All right, x is equal to 24 minus y. Actually, I'm not going to put a box around there, but I do know that this is the same thing as x. So anytime I see an x over here, I can put in 24 minus y. And this is where we want to be a little careful because I don't want to write it as that times y. I always like to write my singleton in front because then it's really easy for me to see distribution. So y is going to equal 24 times y. I like this now because I only have a single variable. Now, what are we looking for here? Let's read up in the problem again. We got to find the dimensions of the garden. So we got to know what x and y are. Okay, I think we can handle this. So 108 is equal to 24y minus y squared. Not digging the negative y squared, so let's bring everything to the left-hand side, sort it. So y squared minus 24y plus 108 equals 0. So I took these guys and moved them to the other side. And I did it because I didn't like that negative y squared. Let's see if this little guy factors, or big guy, because those numbers are kind of crazy. So x squared minus 24x plus 108. And that gives me, I think it does give me nice integer factors. There's one of them over there, so I kind of like it. That's 1, 2, 3, 4, 5, 6. All right, let's find out what the other one is. Change my axis over here. Oh, it's giving me a hard time today. Let's try 30. Probably went too far. Sure did. All right, just so I don't have to count, I'm going to find that 0. And that's 18. So what is it, 6 times 18? Yeah, this is totally it. If I did the box method, I'd be able to see that pretty easily. So y minus 18, and then y plus 6. I knew that because this was negative here. So I wanted my bigger one of those two numbers to be the negative. And when I solve for y, I'm going to get y equals positive 18, and y equals negative 6. We're going to reject the negative 6 because that doesn't make sense. But what I do know is that my y, which was my width here, I don't know why this isn't letting me roll. But my width right up top here, you can see is my y value, and that is 18. And because of that, I can actually say that the width is 18 feet, I'm pretty sure, or was it meters? I better check up here. Meters, of course it is. And then we need to figure out the other value, but we can do that by using the formula. Area was equal to x times y. In this case, our area was 108. So some of you are like, well, Mrs. Ruscio, we already know that 18 times 6 is 108 from above, but I'll just show you in here how we can do that. X times the 18 that we knew, we would divide both sides by 18. We would divide by 18, and we would get x is equal to 6. So the length is equal to 6 meters. I'm pretty sure. Let me just double check. The length is represented by x. Did we do that correctly? Length is x. Absolutely. So here's my final answer for question number 2. Okay, heading on to question 3. So we have a park, and it's going to renovate its gardens. One garden was originally a square, so draw a square, and it's going to be adjusted so that the length is changing and the width is changing. So right away, we know that we're taking something from a square to a rectangle somehow, some way. Let's think about this here. They didn't give us any information about the length or the width or any of that, but what I do know is a square, if we label one side x, all the sides are x. I do know that it's talking about area. So there's a couple things that we notice here. If I wanted to find the area of my square right now, because I knew that if I label one side x, because I didn't know anything, I know nothing about the side lengths, I can label the other side x. So if you think about this, the area on this one is just x times x, which is x squared. I don't know if this is helpful or not. I'm just going to do it. I think it's good to talk things through. Okay, and it said the new rectangular garden is going to have an area that's 25% more than, we'll hold the phone for a minute, 25% more than the original square garden. 25% more than, aren't we comparing that to 100%? Aren't we doing 100% plus 25%, which is really 125%? Holy cow, that is multiplied by 1.25. This is like exponential functions coming back at us in a weird way. All right, hold the phone. Let's rewind, because now I've done nothing with my rectangular garden. So let's see. So the sides are adjusted so that one side is doubled in length. Well, that's easy. If it's originally x, doubled is just 2x. And then the other one is going to be decreased by 3. Oh, I guess I drew the picture in a weird way, but you get the picture. So x minus 3. So this x became x minus 3. That became 2x. So if we're talking about area, let's just find the area of this guy. Wouldn't the area of this equal 2x all times x minus 3? And if you want to get really fancy, you could say it's 2x squared minus 6x if I distribute it through. Potato, potato. All right, so wait a minute. We know that the new rectangular garden, so the new one, so this is the new, this is the old. We know that the new garden is going to have an area that is 125% of the old. So new is equal to 1.25 times the old. The new, the 2x squared minus 6x is going to be 1.25 times the x squared. Interesting. There's my equation. That looks a little scary. I'm guessing that they're going to tell us to figure out the sides. Oh, no. Wow, let's read the directions here. It says determine the area of the new rectangular garden. But in order to get the area, pretty sure I got to find the side lengths. So this is a super interesting question. So what? 2x squared minus 6x is going to equal 1.25x squared. All right. Well, I only have a couple choices here, but I have an x term, so we have to set this equal to 0. So let's bring the 1.25x over to the other side with the 2x squared, or subtract 1.25 from both sides. Either way, we're going to get 0.75, well, 0.75x squared minus 6x is equal to 0. It looks like it has a GCF. I mean, we could try to pull out a GCF of the decimals, but you know what? Let's just pull out the GCF of x, right? Do you guys see that there's x's that are common to both terms? So 0.75x minus 6, which means I'm going to show some math here. We're going to set both of those parts equal to 0. X equals 0. That doesn't make sense. You can't have a side length that's 0. Let's hope that this side gives me a better option. So what's that? 0.75x is equal to 6. And what is 6 divided by 0.75? Let's use our calculator for that so I don't make any calculation errors. Ooh, that's fun. X equals 8. All right, so here's the deal. We got x is equal to 8. We got to find the area of the new garden. So the area of the new garden is 2x squared minus 6x, right? So if we now know what x is, we can just do some awesome substitution. And you know what? I just really like using my calculator because, not because I'm lazy, but because it's so easy to make mistakes. And using a calculator to aid with simple math stuff like this at this point, when you're doing so much other algebra, it's not working, you're not lazy, you're just working a little bit more efficiently. In this case, we would have 80 is equal, or area is equal to 80 what? What's my unit? We're dealing with area, so we got to square it. Meters again, so meters squared. Holy cow, that was a fun and crazy question. Peace out.